Welcome to Theory of Computation class. In today I am going to give an explanation for multiplication operation using Turing machine. So here for the multiplication operation there is a need of two variables and we do a multiplication of these two values m and n. Either we can do multiplication operation, otherwise we can do repeated addition, that is adding m values repeatedly by n time means also we can get the same answer. So for example 3 star 2 is 6, instead of that if you add 3 by 2 times, that means n number of times you can get the same number. So we are using the repeated addition concept in this process. So the generalized format of tape value is initial blank space, then m number of zeros. For differentiating m number of zeros and n number of zeros, the intermediate value is set as 1. After that 1 is available, followed by blank spaces are stored. So what is the purpose of the right side of n1 means we are copying m number of zeros by n times at right side of second one. So we do the process for implementing multiplication operation. Here for example, I am taking m value as 3 and n value as 2. So the tape format is blank space, m number of zeros followed by 1, then n number of zeros followed by 1. After that many blank spaces will be available. So what is the logic behind this concept means, first we are replacing the first mth zero as blank space, then we go to nth zero. So this m, that means I am writing here the m0 is replaced as a blank space and move to right direction. Then n zeros will be replaced as x, then move to right direction. So this is the logic. So this will be changed as x. Then go to right side. After that blank space is available. That blank space is changed as 0, which means that we are copying the first m0 value at this side. Then again come to left direction. We are reading the second nth zero. It is also replaced as x. Then go to right side. The second blank space is replaced as 0. So what is the meaning means we are copying n number of zeros by one time. So this two zeros values are replaced as x. Instead of that the right side blank space values are filled as 0. So this is a one time process. Then I want to go to mth zero value. So once again we repeat the same process. So here the nth zeros are replaced as x. So once again we are replacing it as the original value for doing the second process. So this x are replaced as 0. Go to the second m0 value. Replace it as blank space. Again come here. The first n0 value is replaced as x. Then move to replacing blank space as 0. Come to left side. The second 0 is replaced as x. Go to right side. The fourth blank space is copied as 0. Come to check whether any pending zeros are available in n value. So it's not available. So we should go to the third mth zero value and do the same process. For that once again the x has replaced as 0. Then go to the third process value. Then the third 0 is blank space. Come here. The 0 is replaced as x. Go to right direction. Blank space is replaced as 0. Come to this side. The nth 0 is replaced as x. Go to right side. Then the next blank space is replaced as 0. Come to check here. All the n zeros are replaced as x. Stop the process and change it as 0 for checking the next m0 value. And we come to check here, there is no m0 value is there. That means that the copying process are completed for m times. That means what we do, we are copying n number of zeros by m times. N number of zeros by n times. This is the logic for processing this concept. So finally, the tape contains blank space 1, then n number of zeros, 1 followed by m into n zeros, then blank space is there. The final answer means only m into n zero should be available in tape. So the previous 1 to 1 values, these all values should be replaced as blank space, then go to final state. This is the logic. So for that, I write the steps. So in step 1, first store m number of zeros and n number of zeros in the above format. So what is the format? Blank space, m number of zeros, 1, n number of zeros, 1 blank space. So this is the given format. In this format, we should store the m number of zeros and n number of zeros in an input tape. Then second step, replace the first m0 as blank space by our procedure. So we do the process. So here I write the example. So this will be replaced as 0. Then change the state, because we are replacing 0 as blank space. So we should change the state and go to right direction according to our procedure. Then if you go to the right side, 1 will occur. So if a tape head read 1, until reading 1 you should stay in the same state. So if you read 1, only change the state and go to right direction. Why we are changing the state after reading 1 means for differentiating m number of zeros and n number of zeros, we are only changing the state. So if you change the state, then n zeros are occurred. So this is the fourth step. If tape head read y0, what is our procedure? That nth zero is replaced as x. So this value will be replaced as x. And change the state, go to right direction. So if you go to right direction, the second one will occur. If 1 is read by the head, change the state with the right direction. We should change the state for changing the blank space as 0. So sixth step is, if tape head read blank space, change that blank space as 0. So this blank space will be changed as 0, and we should move to left direction until yn zeros are occurred. Y means here I am replacing it as n zeros. So if you replacing blank space as 0, go to left side. If 1 will occur, go to left side, 0 will occur, go to left side, until x occur, you do the same process of movement of left direction. Then you should change the second n value as x. So in which step it is available? It is available at the fourth step. So we should repeat step 4 to 6 for replacing n number of zeros as x and corresponding blank space as 0. So here n value is 2. So I change the first 2 consecutive blank space as 0. So the process is over. And we should go to the m number of zeros and do the same process. So if you want to do the same process, the replacement of x should be come to the original 0 value. So that is available in 7th step. Repeat step 4 to 6 for changing all zeros as x and blank space as 0. After completion of step 7, replace all x as 0 in that n value. Then go to step 2 for changing the second process. So I want to continue the same process. So the second m0 values are replaced as blank space. Come here. These zeros are replaced as x. So corresponding the next third and fourth blank spaces are replaced as 0. So after completion of that one, the original value should be saved. So this x will be replaced as 0. These x will be replaced as 0. Go to left direction. And change the last 0, mth 0 as blank space. And you replace these zeros as x. And the next immediate 2 blank spaces are replaced as 0. you go to left direction, then this x will be replaced as 0, 0 like that. So you should repeat step 2 to 8 for replacing all x as zeros in a blank space representation. So after completion of all these process, that is after completion of copying n number of zeros by m time, we should come to the 10th step. So what is the 10th step means? Finally the tape contains blank space 1, then n number of zeros, 1 followed by, this is m into n number of zeros. So this is a generalized format. So look at here, these are all blank space 1. I am having n value as 2, so 2 zeros are available, then n, here m into n number of zeros are available, then blank space. So this is finally occurred. So what should we do means, the tape should contain only m into n zeros in a tape. So the remaining value should be changed as blank space. So we should replace the first one, then n number of zeros, then the second one. So we should replace all these values as blank space, then we should go to final state. So this is the logic behind it. So I will give the explanation for the implementation of this problem in a next class. Thank you.